We're gonna use all these. You should. Are you sure?
It's on right now. Do something.
I'm gonna be wearing these
Yeah, it's on.
We're gonna use all these intros for the variety show. By the way, the variety show is only 3 weeks away.
Thanks for trusting me.
What's that?
Thanks for trusting me. I turned it on.
Are you guys gonna go?
Yes.
Totally. On this.
Oh, heck yeah.
I feel like the variety's the same thing the whole way through.
You think it's what? Go ahead. You're bitter.
I was making a comment about how it's the variety show,
Yeah.
but there's not a whole lot of variety. It's just all teachers.
It's all
Similar people up
It's
there.
just summer's hits after hits. Just keep on coming.
Yeah.
It's like, hey guys.
I would fall down a lot.
We are starting. Okay. We're starting chapter 13 today, which is new and different. Again, I told you this a couple times, but all the chapters in this semester are sort of different. There's the piece that relates to really is stoichiometry, which I know that you hate. So we'll see that again later at the end of this chapter. But we're learning about solutions, and today's sort of lecture is really short. Tomorrow is Kool-Aid Friday, which you'll enjoy, and then so we're learning things.
Kool-Aid Friday?
Yeah, Kool-Aid Friday.
Bring my own?
No, I'm going to provide it for you.
Okay.
Unless you want to bring your own.
Oh,
What
what flavor are you doing?
I don't
You
know.
got grape? Don't do orange. Please don't do orange.
So you can't bring your own Kool-Aid unless
Yeah.
you want to.
Do
I'm
bread
gonna
or
do, there's a milk flavor,
Oh my god. Bacon.
bacon grease,
Is there eggs?
eggs, the breakfast.
He's not very attractive. It's a big muffin. Muffin flavor.
This actually McDonald's grease.
Is this recording?
I think so.
Yeah. See.
Oh, it is. Anyway, solutions, different, but there'll be some common threads. The start of this chapter starts off with a review. I think you already kind of remember about mixtures and solutions and how it all fits together, but we talk about mixtures as being either homogeneous or heterogeneous. Heterogeneous mixtures mean that they are not uniform throughout, so like sand or salad. I tend to think about, and although you shouldn't, you should obviously never eat anything in here, but I tend to think about heterogeneous and homogeneous in terms of like eating or drinking. It doesn't taste the same, and so obviously not applicable here, but a salad, every time you jam your fork in there, it's different, or
Sand.
sand, every time you put some sand in your mouth, it tastes a little bit different. It's always good, but it's just always good. Weird.
Dry.
Homogeneous, on the other hand, tastes uniform throughout. So like soda, Diet Coke, like every drop tastes exactly the same. That's the idea. No, it's the same.
Oh, one side.
Well, we don't have ice in it, because then it'd be heterogeneous. It's supposed to be homogeneous.
Well, then why did you first?
I'm sorry, I did. You just weren't listening.
No, you didn't.
A solution is a special kind of homogeneous mixture. And it is of two or more substances uniformly dispersed throughout a single phase.
Is it homogeneous or homogeneous?
Homogeneous, I would say, but I'm
Because I've
pretty sure you can hear either one. Sorry.
Whoa, buddy.
Sorry guys, it's not so great. I gotta do this real quick, so hold on.
Oh.
I know. Oh, it's the other one, which is fine.
Two more substances in the same phase.
Sorry, one. Sorry.
Easy.
Sorry. There we go. I'm the worst teacher you've ever had.
Ever.
Not even close. Clinics.
Why do you like Linux?
It's free.
Don't you guys get like discounts on Windows 7 and stuff like that?
Yeah, and luckily for me, my huge teacher salary allows me to take advantage of this.
What do they make you get? Like, do you guys get free Mac operating systems? That would suck.
We really can't discuss on camera what I'm doing. Sort of under the radar. But if you want to talk about it another time, I'll be happy to. No offense, yeah. This is totally legal and fine. So, so back to solutions. People tend to think of solutions as dissolving a solid in a liquid. That's not always the case. You can put, you can dissolve a gas in a liquid, like the carbonation in your Diet Coke or whatever. You can dissolve, or you can mix two liquids together, and then they cool to become a solid. That's an alloy, like steel. You mix them together. They're all melted metals. You mix them together, and then they cool, and they form they form a solution of two metals that are in one phase. In this case, a solid. So, did you have a question?
Yeah, so if you mix the same amount of like sugar and salt and melted it, would that be a solution? Would that still be a suspension?
That'd be so you mix the solids together,
Yeah.
and then you melt them down,
Into like a liquid or something.
and then they can cool together in something new. If
Yeah.
it cooled and it was one thing, I don't know if this would actually happen, but like let's say you do that and it cools and it's like one block or giant chunk of crystal or whatever.
Yeah.
That's a solution. But if it cools and it's like, and you can like break it apart, it's like a piece of salt here and a piece of sugar
Okay.
there, then it wouldn't be a solution. It would be a
Alright.
mixture that would be, and you can break apart. Another kind of mixtures of suspension. And we'll look at both. The suspension is a mixture in which particles of material are more or less evenly dispersed in a liquid or gas. The difference is that in a suspension, the particles settle out. So a good example of a suspension, something like a delicious glass of muddy water.
More oil on water.
Lemonade,
What's that?
Money water?
I love muddy water. Lemonade is going to be a solution, but a suspension would be something that settles. And so if you mix something up and it looks like it's all uniform throughout, like let's say some literally mud in water, and you mix it up, it looks like it's all one thing. I wish it was money. But anyway, it all looks like one thing, but if you let it sit there for a couple minutes, it settles out, and you have some water and then some mud solid sitting at the bottom. That's a suspension. It stays like that for a little while, but once it settles out, and you can clearly see that it's two different things. That's a major difference. Now, a solution, your Diet Coke, you can keep that, forever pretty much, and it's not going to settle out into its individual pieces. My brother, when he graduated high school, when I graduated high school in 1997, my brother, there was this girl, and a long story, but she came, and then she came to the party, and she brought my brother a thing of like Mountain Dew, a little half-liter bottle of Mountain Dew or whatever.
Nice.
And he kept it for some reason, and it kind of turned into this running joke for my family, and now that's still in my refrigerator 13 years later, is this bottle of Mountain Dew, and it doesn't settle out into like, pieces, or like, it's not like water on top and like Mountain Dew mix on the bottom. It is still exactly the same. I mean, it wouldn't taste very good. It's probably
Is it
disgusting.
open?
The bottle's all distended and stuff because I think it loses all of its carbon dioxide and stuff. It's pretty fun. Anyway, it's kind of a family joke that you guys are now part of. Yeah, good story, right?
Conversation topic.
Say it
Yeah.
over your house. I actually enjoyed it.
it was a good story.
You'll love it.
Okay, so suspension, they settle, that's the major difference. Solutions are stable, homogeneous mixtures, they don't settle out, they remain the same. That's the major difference. The solution has two kind of ingredients, quote unquote. The primary ingredient is the stuff that's doing the dissolving, we call it the solvent.
What are the examples?
Well, the most common solvent is water, so if you're going to mix, let's say, Kool-Aid and water, the Kool-Aid powder, that's going to be not the solvent, and the water is going to be the solvent. The Kool-Aid is going to be the solute. Is that word already highlighted for you?
No, you don't have that.
There it is.
Where you go for?
So- He's his own right now. So solvent is what does the dissolving. Solute is what's being dissolved. And we can go through lots of cases, but if you're going to make a lemonade, if we use Bork's example, lemonade, the powder or whatever, if you're making like generic country time lemonade, the powder is the solute, the water that you dissolve it in is the solvent. Water is the most common solvent, it dissolves the most amount of things, but you can dissolve lots of other things. You can dissolve things and other things. For example, you can take, let's see, how do I put this? Okay, but that's water-based, so that wouldn't work so well. But you can, if it was an alcohol or something, you could dissolve other solids and alcohols and things like that. So water is the most common solute because things that we drink or use are usually water-based, whether it's Diet Coke or whether it's the Glass Plus if you squirt on your glass to wash your mirror or whatever. Water is the major ingredient in that, and then the other pieces are dissolved in there. Even in a let's see, how do I say this appropriately? Even in alcoholic beverages, which you have no idea what they are or
What is
how
that?
they work. Yeah, I don't know.
What are
But those, water is still the major solvent, and the solute in that case is alcohol, and there's other flavors and stuff in there too, but the alcohol, the ethanol is what's dissolved in the water, and then that's when you see let's see, how else do I say this?
Just a great example, 'cause I don't know.
When you see
What do you want, man?
on
movie.
on a movie
A movie.
or
and
in
somebody
Hollywood,
drinking
it's very
alcohol.
stylized or whatever, but on the bottle, they measure how much alcohol is in there by the proof system, which is just twice what the percentage is. That's just how much alcohol is dissolved in the water. You don't care,
Bill
because that
Nye
doesn't mean,
over here.
it's not important to you, but I'm just saying. it's
For a couple more years.
Yeah, a couple more years.
Like 5.
Like 5 for you.
5.
Water is the most common. It dissolves lots of things. It's sometimes called the universal solvent because so many things can be dissolved in water. Since we have this kind of water so common, the solutions that are water-based are called aqueous. I think you've heard that word before, or aqueous.
Yeah, we use
True.
that. We use that when we.
Yes.
Oh,
but we use that in our solutions. All the solutions that we've used in here, for all, like for example, the last lab we did with the hydrochloric acid, and we poured it out into the tall tubes. All of those are water-based. They're all aqueous solutions of hydrochloric acid. And at some point, the hydrochloric acid, well, not in this case, but it was probably a solid dissolved in water, and then it went to death. You can mix one solid with another solid. That's called alloys. Very common. Steel is not just one thing. There are like thousands of types of steel, and they come from mixing different percentages of each metal that goes into steel. Who knows what it is? Nickel, probably. And some other. They put carbon in it sometimes to make it stronger. They put other things in it to make it more bendy. But steel has like thousands of different types. I think I told you before when they had the Olympics in Beijing 2 years ago.
Yeah.
1 year ago. They invented a new type of steel to make the bird's nest where the Olympics were held.
But
At
that
a big
was
stadium.
expensive.
What's that?
But that was expensive.
I bet it was. It was billions of dollars, wasn't
So do they just like throw it in a big pot?
it? Sure, yeah, it's melted in a giant pot, I guess you'd say, and then poured into like molds. And then it cools, and when it cools, it's one thing.
Okay.
But it's really a mixture of,
A bunch of
many
different
yeah.
solids.
Brass, bronze, those are all alloys as well. They have a specific type, a specific percentage of each. I don't know what element goes into brass, but usually it's nickel and copper and something else. But brass and bronze, or chrome, if you are rolling on dubs,
Like man.
that is an alloy of different metals. Colloids, we don't really care about too much in here. Colloids are certainly in between a suspension and a solution. Milk is a colloid where it's actually particles of fat sort of suspended in the water, but you can separate them out. I don't really care, but that's how milk works. Mixtures can be separated lots and lots of different ways. And they're always separated based on physical properties. If you wanted to separate out someone who was old enough, who owned an alcoholic beverage, you could separate it out because it's made up of water and alcohol, and one of the ways to separate that out is by distillation. Okay, they have the alcohol and the water have different boiling points. So the way that works is you put them into essentially a well, I don't know. Did you guys distill anything when you were a freshman?
Yeah.
You basically put it into a place where it boils. The alcohol is a lower boiling point, so it boils first. When it boils, it gets converted into a gas. The gas goes up into a little cooling tube, and then when it cools, what happens to it? It condenses back into a liquid, and then that separates out on this side, and you have the alcohol here and the water here. Just tell them how to distill alcoholic beverages. By the way, we're on camera, so go ahead and ask for whoever you want.
Max.
He's not here. He's in Ohio.
Isn't distilling how you
Indiana.
He's in
He's in Hawaii.
He's in another state.
Yes.
All week.
Well, starting today. the rest
He'll
of
be
the week.
back on Monday.
Now you guys know where to find him at home if you're watching.
Yeah.
Hilarious.
All you old men out there.
All right, so that's just one way to separate a mixture. Let's see what else. You know, if it was a mixture of iron and sand, you can separate it with a magnet because iron is magnetic, sand is not. If it's a mixture of sand and water, you can separate it by doing what?
Filtering it.
Filtering it out. Or the water-sand mixture into a piece of filter paper. The water obviously goes through. The sand doesn't. There's lots of different ways to separate stuff, but it's all based on physical properties. That's the most important part. You can't separate, well, you can't separate on chemical properties, but separating on physical properties is the way you separate a mixture. I mean, something as simple as pouring off the liquid. A centrifuge we don't get to use in here that much, but if you like chemistry, I guess you actually can't take AP unless you're a sophomore or a freshman. But anyway, if you could, they use centrifuges more often there in AP chemistry. It's basically you have like a suspension, like let's say
Blood.
some sort of solid sitting in water.
Like a
And, you know, it
force
looks,
field.
and your centrifuge just spins it around really fast, so the solid goes to the bottom, so water stays up top. It's an easy way to separate stuff.
Oh, I've never.
Yeah, that's pretty common. We just don't use them that much in here. We'll get to chromatography in a second. We're gonna last. I already told you how to distill something.
What is that from?
So distillation is separated. Boiling points. That's really common in solution chemistry because you have mixtures of different things.
Miss Black Spot.
I know I'm gonna go
What is
back up
that?
there. Don't worry.
Okay. What is that from?
What from? Sorry.
Every time Woody
The light there? That's the light.
Oh, okay.
Yeah.
Yeah.
Oh.
No, he's got a
Angles.
camera inside the TV.
Like that.
Oh.
What was it?
Wait, how did it go again?
How does it go from here to the table?
Magic. Lasers.
See, it's still on TV.
I already explained how that works. I would draw you a picture, but I think you've already done that before. Oh, and the last one we're going to do is I'm going to show you how it works with chromatography. Chromatography is actually really common. You probably did something like this in second grade or something like that, and I'll show you in a second. But chromatography works because molecules that are dissolved in stuff, they move fast or slow relative to other molecules. And some molecules like to stick with water, and so as the water, let's say with a piece of paper, it drags the lighter weight molecules with it very easily. But the heavier, fatter molecules, they don't like to stay with the water because it's difficult for them to go up to on the solid phase on the piece of paper, and so they stay down towards the bottom. It's an easy way to separate out mixtures based on molecular size, which is again a physical property. And so this is pretty common. Use it to pretty common in especially in organic chemistry, but you know, if you get to college and do something like that, but if you ever have separate out the mixture or marker, which I'm going to do in a second, that's pretty common. It's a way that you separate mixtures. Kales, we're good.